Hi, I'm recording this video to supplement the end of Tuesday's class on September 23rd. We didn't get to finish everything in the first section and we finished really fast in the second section. So if you'd like to review, I am looking at the homework paper that we got at the end of class, part 2. And what I'd like you to know about this first part of questions here is that get a pencil, is that this whole piece right here, you don't have to use the formulas for this. You certainly can, and you will get the right answers. But whenever is in number 1, it says combination of 5, choose 0, or n choose 0, where n just represents any number. The only way that you can pick nothing, there's just one way to do that. And it's been defined as 1. You could argue, how can you pick nothing? But it's been defined as 1. And you might also like to know that 0 factorial, I don't have very good pencil here, is equal to 1. So that's a 0 factorial is equal to 1. So if you think about that, anytime you're picking 0, there's just one way to do it. Now moving on to number 2, if you're picking one thing, in the first case, we have 5 elements. So you could pick each of those 5 elements. So there are only 5 ways to pick one thing. In class, in our example, we had 3 elements. So you could pick A, B, or C. There are only 3 things you could pick one at a time. So if you have n things one at a time, there are going to be n things you can pick. The third one, you're picking all the things. So 5, choose 5. If you imagine yourself reaching into a bowl of marbles, you're picking all the marbles. There's just one way to grab them all. Because remember, order doesn't matter. So you just reach in there, you grab them all. That's it. There's one way to do it. So combination n, choose n. N is just any number, and you're picking all of them. So the result would be 1. And then the fourth one, what's interesting about these is the first number is 1 higher than the second number. So 3 is 1 more than 2, 4 is 1 more than 3, and n is 1 higher than n minus 1. So in all those cases, the combination ends up just being the higher number. So this is really similar to the case where we were just picking 1. If we're picking everything but 1, we're leaving 1 behind every time we make a choice. So there's always you can only leave 1 behind at a time. So however many options you have, the bigger number will be the result. So again, you could use this formula up here, but you don't need to in these cases. I'm going to erase that. And let's talk about the last 2, and then we'll talk about 2 more problems that we would have done in class. So number 5, this we would have done in class, a very similar problem. We have done this problem the first way in the past. So you have 9 numbers. You want the probability that they're both even. So you're picking a number and you're picking a number, and we're going to multiply them together. That's a dot right there. So even numbers are 2, 4, 6, 8. So there are 4 even numbers out of 9 total numbers. Now you lose a number because we're picking 2 distinct integers according to the directions. So now we have 8 numbers to pick from. We already picked one of the even numbers, so now we have 3 left to pick from. So our result is, if we simplify this a little, it's going to be 1/6. Sorry about the bad writing, I'm using my mouse. If we were to do this again using combinations, and the goal is here to show that we do get the same answer, we're just thinking about the problem a little bit differently using this new tool we have, which is the combination. The combination is super useful. So we're thinking probability because we're asked for the probability. So we want all possible options, and that goes in the bottom, and then whatever we want goes in the top. So what we want is 2 even numbers. So this is a combination. The order doesn't matter. It's just that they're both even. There are 4 even numbers to pick from, and we're going to pick 2. And then all the numbers, there were 9 numbers, we're going to pick 2. And you can see here, if you work out a combination of 4, 6, 2, 4 choose 2 is 6. A combination of 9 choose 2 is 36, and that reduces to 1/6. If you want to know how to put that in your calculator, ask me. I can show you how to do that. And then finally, we've got this bag of marbles. We have 5 plus 4 plus 3, so we have 12 marbles. we want to know how many ways can two marbles be selected such that they are both not red. That language is a good clue that the complementary method would work better, because otherwise we have to count when they're both blue and both green, and one is red and one is green and one is blue and one is green, and all those things. It would take forever to do all those cases. So we can count all the ways to select two marbles. So there are 12 marbles and we're picking two. Then we subtract out all the ways to pick two red marbles. There are 5 red marbles and we're picking two. So in class, what I'm going to have you do is you might write a combination like this, and then I'll have you remember that this is 12 factorial over 10 factorial, 2 factorial. But if you want to know how to put this in your calculator, like I said, so that you can actually get the 66, I can show you how to do that. Also, if you just look at this, 12 factorial is 12 times 11 times 10 and so on, and this 10 factorial will divide everything down from 10. So you're going to be left with 12 times 11 over 2 factorial, which is just 2. So you could multiply 12 times 11 divided by 2, or 12 divided by 2 is 6 times 11 is 66. So you could figure it out that way. Okay, let's switch over to the last two problems we would have done in class, which you can see in the notes. And number 11, as you see here, is the same problem. It's just that they're both odd. So it works the same way. And then this last one, number 12, we've got a 5-animal group is created from 3 reptiles and 7 fish. What is the probability that the group has at least 1 reptile? So at least 1, that's a clue that the complementary method will work better, because otherwise we have a whole bunch of cases to consider. So with the complementary method, we'd count all possible groups, and then we'd subtract out all possible fish groups, because all we have are reptiles and fish. So any group that has at least 1 reptile would have to have no fish in it. I mean, could not be all fish, because 1 reptile would stop it from being all fish. So again, we want a group that has at least 1 reptile. So what we don't want is a group with no reptiles in it, and that would be a group that only has fish in it, or what I'm calling an all fish group. So how many groups can we have? Well, we have 3 reptiles and 7 fish, so there are 10 creatures. We are picking 5 because it's a 5-animal group. Then we're subtracting out groups that are all fish. There were 7 fish, and we would be picking 5 to all be fish. And then you can see these are the formulas for combinations that I've worked out what the numbers are. You would not need to do this on a test. And then I'm just rewriting. So this top part is the number of groups that would have the possible groups minus the all fish groups. So these are the groups that we're interested in, 231. And then the question was, what is the probability? So we have to divide by all possible groups. There were 10 animals, pick 5. So total number of possibles, 252. And then you can see I simplified here. I realize this isn't the best video, just doing it quickly. Hopefully it helps you. Please send me an email or whatever if you need more help on this. I'd be happy to talk to you about it.